to start Unit 2. Let's check this out.
See an attempt here at an all-time record field goal in NFL history. We believe it'll be from 64 yards for Prater. 63 the record for Scott Dempsey, Jason Elam for the Bronco, and now for the all-time mark for 64.
Hey, this guy goes wild.
What is that? Everyone knows. He recorded the YouTube video.
But it was that epic. He was recording the highlights. So what kind of questions could we actually answer about that kick? Think about modeling that with math. What would you be able to answer? What is it?
I was going to say something like triangles. So we did like kind of like.
You're on the right track. But what kind of shape? Is it making a triangle shape?
You could make an absolute value of like the feet and then the height.
So, but that's still a triangle, though. I heard a word starts with a P.
Parabola?
Parabola. What shape is a parabola for people who are thinking that way? Yes. So I'm going to pass out this Unit 2 pretest just because I'm going to pass it out this way. Pass it that way. Just so we can have a quick survey of the unit we are about to undertake. Should be enough for this pocket here. So take a second, and I just want you to circle anything that you feel you're familiar with. You're welcome. Take a quick moment. This is this. Why do you have hers? You should be copying. Okay, so take a quick second, look at the questions, like treat this like a survey, and I would like you to circle any and all parts, words, vocab words that may look familiar. We'll be revisiting this throughout the unit.
You don't want us to answer the question?
If you think you can answer it, go ahead. But I'm going to stop you in about a minute because this is just a quick, can we get a mental snapshot of our unit? Was anything like a standout moment for you on the front page? 0. What number was that? Number 4? What do you know about 0? No, but it sounds familiar. Sounds cool. I agree, it sounds cool. Sounds cool. Anybody else?
Factor.
Where? What number?
Right there, next to 0.
What does it mean to factor?
Like numbers, like that go into something.
Who has a vague memory of factoring? Awesome. I'll take vague. Cool. How about numbers 6 through 11?
It's back on the front vertex.
Discriminant is going to be a keyword. Where did you see vertex?
Number 3, number 5.
Number 3, vertex, and number 5, vertex. Why is that word standing out to us? Because what function had a vertex? Yes. So just like vertex, just like absolute value has vertex, so do quadratic functions. Yes, Malaysia. Shifting. Where do you see the word shifting? Number 1? Why is that standing out to you? Because we had it in the last unit. So here's 2 or 3 solid commonalities that you will see overlap between function families. Any others? Olivia? Number 2? Anybody graph quadratics before? Yes? Awesome. Have you graphed them before? No, but it looks awesome. I think it looks awesome too. Okay, so keep this in the front of your unit, okay, because this is going to be something we reference. At the end of our unit, we will have this as part of the post-test. So here's a sampling of questions. We're going to take some board notes to start off today on quadratic functions. So coming full circle, we do want to have that shape. It started with a P. What was that shape that started with a P? Parabola. And what shape is a parabola? A U, a curve, a U curve. Very good. That is one of our vocab words that's going to come up in a moment. So today is our first day with quadratic. Today will be all about characteristics, definitions, forms, the meat of our vocab. So the definition of a quadratic function is a function whose x values have a highest exponent of 2. Function has a highest exponent of 2. The graph of a quadratic function Are we okay with my abbreviation here? Quad for quadratic, FN for function, is U-shaped. Make sure that U does not look like a V. U-shaped. And is called a parabola. It has a vertex would this here be a maximum or a minimum? And this would be a minimum. Yes. Story about the highlighters. SAT ninjas. Borrowed them yesterday and did not bring them back. So let me see if I can get out some new boxes. Yes. Say that again? Almost. All right, so who needs a highlighter? There's yellow, pink. All right, so yes, maximum, minimum. Has a vertex, it's either a maximum or minimum, and an axis of symmetry. Do we have axis of symmetry with absolute values? Yes, we did. So it's nice how much of this overlaps. It overlaps a lot. What is the axis of symmetry again? Yes. It cuts right through the vertex and it cuts the actual graph in half. Anybody remember the equation for the axis of symmetry? Yes, and that will still be the case. Very good. We have 3 different forms of quadratic equations, and we will be using all 3. Let's talk about the first one. Three forms. 3. First one, standard form. Standard form. Standard form is f of x equals ax squared plus bx plus c. Well, hopefully this year, no more headaches. She said this gave her headaches last year. We're going to fix that. So standard form, f of x equals ax squared plus bx plus c. Characteristics for standard form. C is the y-intercept. And to calculate vertex, it's going to be xb equals negative b divided by 2a. I'm hearing, what? I'm hearing, oh yeah. Anybody remember this? Or have seen it? About a third of us? Negative b divided by 2a. B. Oh, sorry. Let me address that. So the reason why we have x with a little v, guess what v stands for? Vertex. So it's kind of giving a name to the x value. This is saying the x value of the vertex is, without having to actually write that out. Very good. 2. Vertex form. Vertex form. Now the what? Okay. Vertex form is f of x equals a times x minus h squared plus k. Ah.
That's a lot.
No, but I guarantee you, once we start talking, be like, oh, this is great.
No, you'll probably have to take out.
Well, let's talk characteristics, okay?
Hey, isn't this absolute value formula? Isn't it like squared?
Very good connection. So now, mentally, if you viewed these as absolute value bars, are we right back to where we were last unit? Yes. So, do we have absolute value bars here?
No.
No. These are definitely parentheses. Make them clear parentheses. But what values look familiar to us? This form gives us the vertex right away. No calculation needed.
Right in the name.
H comma K. And it is right in the name. Vertex form gives us the vertex. Our third form that we'll talk and introduce right now is intercept form. I heard that. We'll talk about it in 1 second. So intercept form is f of x equals a times x minus p x minus q. So remember, variables just represent an unknown value. So P and Q could be M and N, R and S. Whatever makes you happy, go ahead and use it. But we have to be clear with what each piece represents. So A, X minus P, and X minus Q are all what? Think back to like the first week of school. Starts with an F. When things are being multiplied together, they are all factors. Are factors. The approach for intercept form will be to set x minus p equal to 0 and x minus q equal to 0. Set each factor equal to 0 and solve for x. To find the x-intercepts, where that parabola crosses the x-axis. How many x-intercepts could there be?
2. So.
2? Could there be less than 2?
Yeah.
Sketch out what you think. I'm going to move this over because it's bothering me. So while I move this over, what would the sketch look like? Think back to absolute value. We've been making some great connections to our last function family. There's a lot of similarities. So what were the possible x-intercepts? So I heard 2. We all agree on 2. Let's get that one on paper. For there to be 2, the graph would have to be shifted where and opening how?
Shifted up and opening down.
Sure. So shifted up and opening down. That would be 2.
Down and opening up.
So 2 x-intercepts. What was the next possibility?
1.
1. For there to be 1, what would that look like?
Not shifting up or down.
Yeah, no vertical shifts. No vertical shifts. Because I want the vertex to sit exactly where? Right on the x-axis. Does it matter if it opens up or down? No. So there's 1 x-intercept. Could there be none? What would none look like? Can you tell me in words? What would the shifts be? Good. So it would be shifted up and opening up. This graph will never cross. Or shifted down and opening down. This graph will never cross. So notice how well old concepts from our last function family really do transfer nicely to this one. There's one more note I'm going to put here. We'll come back to it. XV for intercept form is the average of the x-intercepts. So write that down. Think about what that means, and we'll see if we can make a quick little discovery about that. the x value of the vertex, xv, is the average of the x-intercepts. What does average mean? So if I'm taking the average of two things, you would add those two things together and divide by 2. So if I were to add up these two values and divide by 2, where would I be? X value of the vertex. That's what we're saying. You follow? So with this example, let's make up some numbers real quick. Give me a negative value that would make sense for this number over here. I heard negative 10 first. And this one. I heard 2. 2 sounds good. Let's do negative 10 plus 2. What do you get? Negative 8. How do you finish finding the average? What is negative 8 divided by 2? So the x value of the vertex is negative 4. And we'll come back. Remember, this is our day 1 broad notes. So we will come back to this. But I'm like, oh, but half of us are feeling good with that, which is great. A couple other notes on characteristics. Can I change this slide? Other characteristics. Let's talk about the role of A. What did A determine for absolute value? True. A was the slope, but those were linear pieces. Do we have linear pieces anymore? No. So A is no longer the slope. But what can we still say about A? What else did we say about A last time, last unit? Yes. Positive A, parabola opens. Up. Negative A, parabola opens. Should be an O. Parabola opens. How? Down. There's a lot of similarities between linear characteristics with that slope concept, absolute value, quadratic. When we start getting into some of the more of the cube roots and things like that, some of the characteristics may change, but that same idea of shift, that will be present throughout. The role of A, very good. What was our axis of symmetry again? X equals H. We're going to add in that box X equals X sub V because X equals H only exists in what form? Try again. We have 3. Look at the notes we just took. Which form do we have in H value? Try again. Only in vertex form do we actually have H present. With standard and intercept, we actually have to calculate XV. Good? So if we want to add that note, X equals H only in vertex form. XV, so standard and intercepts need to calculate that value, which is why we're going to be talking about H and XV, both representing that X value of the vertex. talk a little more about the vertex. We're going to use XV, YV to discuss those values because, again, we don't always have, unlike absolute value where we always have H comma K, we don't always have H comma K now. What did H and K determine in absolute value function? The vertex, true, but what about where that graph moved? The shift. So the same principle applies. Here, XV is going to tell me what? Horizontal shift. Left or right. And YV, Y sub V is the vertical shift. Which would be up or down. Domain and range. Again, there's a lot of similarities between the absolute value functions we looked at with domain and range and quadratic functions. So let's sketch a parabola that opens up and a parabola that opens down. For both of these, what's the domain? So sketch them and then think about that. For both, what's the domain? Yes. So domain will always be all real numbers. I come in from the left, I come in from the right, I hit arrows both times. What about the range for this first one? Yes. Is that similar to absolute value? Where the Y value affected my range? Yes. Exact same concept. Let's talk range over here on the right. Come in from the bottom, what do we hit? Negative infinity. But when I come in from the top, what's my biggest Y value going to be? YV. So in words, domain always, all real numbers, range affected by the Y value of the vertex. In the real world, what are roots? If I asked you, like, what are roots, what would you say? Nope, not in math. Roots of a tree, let's go with that. Where are the roots of a tree located? Where do they start? Like right where air meets dirt, right? Roots. So same kind of concept. Roots in math are my x-intercepts. It's another word for x-intercepts. To know how many, like we kind of sketched it out because we know from our last unit, we're going to look at A, because that way we know if it opens up or down, and YV, because what information do we get from that? What kind of shift? Vertical. Vertical shift up or down. So let's reason, okay? I could have a positive A and a positive shift. So this is opens up, and what kind of shift? Shift up. How many roots would there be? How do you know that? What mental picture do you have in mind? It's opening up, and it has been shifted up. So that graph will never cross. What else could I have? So now that you have an idea of what we're talking about, what other example could we do? Sure. Positive A, so opens how?
Good morning, East River High School. Today is October 20th. Please stand for the pledge. I pledge
It's half day, remember?
the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Students are reminded to be responsible by being on time and in uniform, to be respectful by treating others with kindness, and to be safe with words and actions. Have a day, excellence.
How many x-intercepts will this one have? How many roots? 2. So this is helping us to appreciate when we know A and we know the Y value, we can actually know how many roots that we expect to have. 2 x-intercepts or 2 roots. It is a half day, so we are on a shortened schedule. We were going to wrap up the second half of class, kind of summarizing all of our knowledge in a Freyer model. We will start tomorrow's class with this. Tonight's homework is characteristics using the board notes that we had for class today. She worked on that yesterday. Yes. So what I mean by that is that if I have vertex form, just by having that form, I know the x value of the vertex. H is part of the formula I'm given. The other 2, that does not happen. The other 2, you actually have to do math. Yes. Great clarifying question. So let's get started on this, because you may be able to get at least one done. Work till the bell. Good job today. We'll pick up with our Freyer models first thing tomorrow.